Right now, I'm going to run through a couple of ideas of chemistry that we use. We use in conversation all the time. So I shall just refresh your understanding of these. I'll tell you how we're going to use them. Thermodynamics and kinetics. These are kind of the pillars. These are the fundamental descriptions that apply to all chemistry, and they're huge. They're huge and they're complex. But for our purposes, we are not going to do the math of them, but we need to know. You will need to understand what we're looking at. Thermodynamics. Thermodynamics is a way of measuring the energy changes that accompany a chemical reaction. Chemical reaction. Kinetics is the measure of how fast a chemical reaction happens. So the rates of chemical reactions. Let me point out, on the subject of kinetics, let me point out something kind of simple. Chemicals react and change. Sometimes it's fast and sometimes it's slow. And the range in rates of chemical reactions is kind of astounding, really. If you have a pile of wood and you leave it out in your woodshed to heat your house in the wintertime, that pile of wood is unstable with respect to its combustion products. That is to say, if you burn the wood, the content of the wood is converted to CO2 and water, just like a gallon of gasoline, when it's burned, is converted to CO2 and water. And we would say that the wood or the gasoline is unstable relative to its reaction products, CO2 and water. Yet gasoline will burn very quickly and wood will burn slowly. They both burn. But here's another example. I started with that image of a pile of wood. You can say, oh, it'll take perhaps pretty much a century for that just to decompose on its own into CO2 and water, perhaps longer. If you think about the propellant inside an airbag in a car. In an airbag, packed inside, there is a solid material. There are a couple of actually, but sodium azide, NaN3, is probably the major component. Now, that sodium azide, your airbag, might sit in your car for 12 years and you never had an accident. And on some day you get unfortunate, you crash into somebody in front of you, and you expect the airbag, you hope the airbag will inflate, and it will do it real quickly. So the change, I don't exactly know what the balance reaction is, but let's say it's something like NaN3, and that's a solid. By the way, the NaN3 is kind of between two electrodes, which are gold coated. The car might be 12 years old, but you don't want those electrodes to be corroded by the time you need the airbag, so they're coated with gold to protect them. And it produces some form of sodium. I'm not sure, it must be a cation, but the important thing, it produces a lot of N2 gas. So a small volume of the solid produces a large volume of the gas. And you want that to happen quickly. What I'm emphasizing is the kinetics of the reaction. It will happen fast, and if it all works out right, it saves you from being hurt in a collision.